All right, so today what we're going to start off with is solving one-step equations by addition and subtraction. An equation is a math sentence that does contain an equal sign. Just like that. The goal of solving an equation is to find the value of the variable. We do this by isolating the variable on one side of the equation and using inverse operations. Inverse operations undo each other. So we think about what would cancel out. So if I were to say the inverse of addition, you'd think, what is the opposite of addition? Instead of adding, you would subtract. The inverse of subtraction would be addition. The inverse of multiplication would be division. The inverse of division would be multiplication. All right. So inverse operations, you can see that they pair up and they cancel each other out. So if I were to add 3, I could also subtract 3. If I were to divide by 2, I could multiply by 2. Let's look at some examples. I'm going to zoom in a little bit. John has X apples. If he adds 5 apples to his pile, he will have 8 apples. What is the value of X? So it says John has X apples. So we have X plus 8. X plus 5 equals 8 because he adds 5 to it and he gets 8 apples. If we wanted to figure out what it was to begin with before he added the 5 to it, we would simply have to subtract 5 from 8 to figure out what he started with. So when we subtract 5, we're left with X equals 3. Next example, it says Maddie has X dollars after spending 90. So she took 90 and she spent it. She only has 45 left. So what did she have before she spent 90? Well, if we think about spending 90 as taking 90 away from how much she had, then if we want to go backwards, we have to do the inverse. We have to add 90 to 45. And if you do 45 plus 90, you get 135. So if we want to go backwards, we can just think about doing the inverse operation. So John had 3 apples. Maddie had $135 before she bought the purse. And we can check that by plugging our answer that we got back in. So when we check, that means we go back to our original equation, which was X minus 90. And we say, well, if she had 135 before, if we subtract 90, then we should get 45. If he had 3 before and we add 5, he should end up with 8, just like he did. And if we check our math and we type this in our calculator, we get 45 equals 45. And we get 8 equals 8. And that's a way we can check to make sure we got the right answer. Let's practice. Here's a few one-step equations. The first one, it says X plus 2 equals 10. So the inverse of adding 2 is going to be subtracting 2. Whenever we subtract an equation, we have to do that to both sides. And the 2's are going to cancel out to give me X plus 0. And 10 minus 2 is 8. So I ended up with X plus 0 is 8, or X equals 8. Now, if I wanted to check to see if that was the right answer, I would have to plug that back in. So I'm going to go back to my X plus 2 equals 10, but I'm going to replace the X with an 8. Now the question I have for you is, does 8 plus 2 equal 10? And if I type 8 plus 2 in my calculator, I end up with 10 equals 10. So that's perfect. It checks out. Let's look at the second one. The second one is y minus 8 equals 15. So if I want to isolate the variable, if I want to get the y by itself, I need to get rid of the minus 8. I do that by doing the inverse operation. So I'm going to add 8 to both sides. If I add 8, it becomes y minus 0. The 8's cancel out. But on the other side, I get 23. So I get y equals 23. If I wanted to check my equation, I could say 23 minus 8 equals 15. And I can type in my calculator 23 minus 8. And if I do that, I get 15. So it checks out. Number 3, I have a plus 9. So if I want to do the inverse of plus 9, I subtract 9. And I have to do it to both sides. So every time you'll notice we're doing it to both sides of that equation. The 9 and the negative 9 cancel out. 9 minus 9 is 0. On the other side, I end up with 2 minus 9. If I type that in my calculator, I actually get negative 7. So I get A equals negative 7. If I wanted to check my answer, I could plug negative 7 back in, and I get negative 7 plus 9 equals 2. If I type that in my calculator, negative 7 plus 9 gives me 2 equals 2. So it checks out. All right, so that's solving one-step equations using addition and subtraction and doing the inverse operation. A couple key things, I got to do it to both sides. And then my goal is to get the variable, the letter, all by itself. I have a bunch of practice here that you could do. If you want more practice for this, I think you should just pause the video here and try to do a few of these. If I were you, I would do number 1, number 2, number 3, and number 4. If you do those 4 and you get all 4 of them right, then you should be golden. I'm going to tell you the answers. My answers that I got were 11. And then the next one, if I were to add 15, I'd get 37. The next one, if I add 17, I'd get 100. And number 4, I would get 9. Okay, so if that's what you got, then you're in great shape. If you want more practice, feel free to jump on these. I have a bunch more practice. If you ever want more practice solving one-step equations, let me know. I can tell you exactly where you need to go. Next, we need to solve one-step equations, but this time we're going to do multiplication and division. So the goal of solving equations is to find the value of the unknown. Find the value of the unknown. To do this, you need to isolate the variable. And then we're going to do that using inverse operations. As a reminder, we're going to state the inverse by doing whatever the opposite of what's happening. So instead of adding 23, we're going to subtract 23. Instead of subtracting 18, we're going to add 18. Instead of multiplying by negative 15, we're going to divide by negative 15. And instead of dividing by 8, we're going to multiply by 8. First example, we have 8x equals 56. In order to get the 8 away from it, the 8 we have to remember is that we're going to do, where's the variable? It's right there. What is done to it? Well, what is the 8 doing? Well, the 8 is multiplying. And so how can we undo that? What's the inverse of multiply by 8? We can divide by 8. We need to apply that to both sides. And if we do that, we end up with x equals 7 because 56 divided by 8 equals 7. We need to check our answer. So what we're going to do is we're going to plug 7 back in for the x, and we're going to see if it does equal 56. 8 times 7, if I type it in my calculator, I get 56 equals 56, and so it checked out. In example 2, we have a, and then it's over a 5. So what is being done to that a? It's being divided by 5. So what is the opposite of dividing by 5? We're going to multiply by 5. 5 times. And we need to do that to both sides. And if we do that, we get the 5's on the left cancel out, but I have 12 times 5 equals 60. To check to see if that was the right answer, we're going to go ahead and use the original equation. A over 5 equals 12. We're going to plug in 60. And then we're going to type in our calculator. What's 60 divided by 5? It's 12. So we get 12 equals 12. And so that checks out. Now, I've got some practice problems here. We want to do just a couple of them as practice. I'm going to have you pause the video here and just try 1, 2, 3, 4. You ready? All right, I'm going to go ahead and jump on the answer. I know you've already solved them, so we can go ahead and say first one's A equals 6. The second one is B equals 48. F equals 12. Y equals 8. A equals 11. And G equals 49. Don't take my word for it. Check them out by plugging those back in to see if those work. If you want more practice because you didn't get those right, I would try these out for size. Go ahead and pause the video and check them out. We want to look at one other special case, and that's the multiplicative inverse, also known as the reciprocals. So we're going to use this whenever we have a fraction in front of our variable. So to see what this looks like, we need to know the multiplicative inverse or the reciprocal of a fraction. And what that means is we actually just need to write the fraction upside down. So instead of 1 over 3, we're going to say 3 over 1. Instead of 5 over 7, it's 7 over 5. And instead of 5 over 2, or instead of 2 over 5, it's 5 over 2. Now we're going to use it to solve an equation. So since the multiplicative inverse is kind of the opposite, just like we were doing the inverses, we can use that to solve equations where we have a fraction multiplied by our variable. For example, in this problem, we have 3/5 times t. So the coefficient is 3/5, which means the reciprocal of 3/5 is 5 over 3. So what we're going to do is we're going to multiply each side by the multiplicative inverse. And then we're going to simplify it. Now the left side is just t. It just cancels out. That was the whole point of us multiplying, so we can get the t by itself, isolate the variable. On the right side, if I type this in my calculator, I get 6 times 5/3, and it'll give me 10. Now, it depends on what calculator you're using, but I ended up with just 10, and so that is my final answer. If I wanted to see if it worked, I could type in 3/5 times 10 and see if it equals 6. Let's try another example. Next one's 2/7. So in order to get the t by itself, what we're going to do is we're going to multiply by the reciprocal. I'm going to do 7 over 2 and 7 over 2. If I multiply both sides by 7 over 2, on the left-hand side, these cancel out, and I'm just left with t equals, if I do 8 times 7 over 2 and type that in my calculator, just like it's written, 8 times, and then a fraction, 7 over 2, I end up with 28. Here's some quick practice problems for you. If you want to practice, you can go ahead and pause this. All right, I'm going to go ahead and tell you the answer. So if you don't want to know, pause it right now. Here we go. In order to find these, I'm going to multiply by the reciprocal, but I'm going to do it in my head to save us a little bit of time. And I get t equals 21. T equals 10. T equals 54. T equals 10. And then we're going to leave it at that. So if you want more practice, you can try it on these 4, okay?